great, right? Are we mad at the realtor?
Yeah.
You told me it was 1,500, 1,560.
Did he?
No, he said it was less.
Less.
Equal to.
So it was less than 1560.
Less or
So you said less or equal to.
Less than. So this is less than 1560, right?
Correct.
Trick question.
Who's
Sorry.
the dollars?
Sorry about that.
Is it less or
I
equal?
set you right up.
I don't like that.
Alright, so if it's less than 1560, we're like, alright, we're cool. In that case, we might even start using terms like, I accept what you say.
Or what part of town?
Or I fail to reject what you say.
Yeah, I mean, it's like even better than fail to reject. I actually accept. So, let's suppose instead we get that 1586 number again. So, we get 1586. 1586. And now we're like, well, you told us it was less than 1560. I get a number that's more than 1560, 1586. So I'm a little annoyed. Question is, do I throw the brick? Alright, am I willing to say I am confident that you are wrong, I reject your null hypothesis, and I'm gonna get really mad? Do I say that?
Not yet.
Not yet. Let's do some analysis. Good point. Alright, given what the realtor says is true, we'll set up the sampling distribution and the sample mean the same way. We'll look at the equal part, the equal 1560. So we'll say this mean of the sampling distribution sample mean is equal to 1560, assuming what the realtor says is true. And then we'll have a standard deviation. We're still talking to 15 people, or 50 people, excuse me. Population standard deviation of 100. Okay, so again, I came up with a sample mean of 1586. Alright, what is the likelihood of getting 1586? Getting a z-score of 1586. Getting a mean of 1586. Well, in order to answer that question, I need a z-score for this mean. Just like we gave Michael Jordan a z-score, we're going to give this sample mean a z-score. And we did that exact same way we did it with the two-tailed test. 1586 minus 1560 divided by, we want the number of standard deviations. It's the 100 divided by the square root of 50, which came out to be 14.14. Alright, and this came out to 1.84, right?
Yes.
Alright, so same question. What is the likelihood of getting a z-stat that high? 3.3%. There's a 3.3% chance of getting a z-stat that high if what the realtor says is true. So this is 0.033. Now, how many ways are there to disprove this null hypothesis? Last time, we found that there were two ways to disprove it, with either a really, really high sample mean or a really, really low sample mean. How many ways could we disprove this null hypothesis? One way, only with a really, really high sample mean. Really, really low sample mean, we're like, yeah, that's fine, that's cool. So, we do not, in this case, need to double this percentage. This is our p-value. P-value.
Wait, how did you go from 1.84 to 3.3% again?
Okay, we looked on the Z table
Oh, okay.
and said 1.84 separates the upper 3.3% from the bottom 96.7%. Alright, and let's suppose we were looking at a significance level of 10%. What is our fail to reject decision? P-value is 3%. Significance level is 10%. Do we reject or fail to reject? reject the null hypothesis. It is less likely than 10%. So we go, throw the brick through the realtor's window. We say, we have statistical evidence that you were lying to me.
Is that because the p-value is 3.3%?
The pre-value is 3.3%.
So because it's less than 10%?
It's less than what we're willing to believe.
Okay.
Okay.
Yeah, we're not willing to believe anything less likely than 10%.
Okay. And how do we know that it's a one-tailed test?
Because there's only one way to disprove the null hypothesis.
And that's because it's the greater than or equal to
Yes,
versus an equal sign like we did in the two-tailed.
exactly, exactly. Just like Marie found out that if the sample mean comes out to 1200, we can't throw the brick. All right, now question for you all. Suppose we go to this realtor's office, we throw a brick through his window, and what is the realtor going to say in his defense? What could he say, if he has maybe a statistical background?
He's saying the sample size is too small.
No, he could say, he could say you need to sample again.
Yeah.
Yeah, he's gonna say you need to sample again. What else could he say that might involve this number?
You need to widen the.
Okay, yeah, he could say you
Broaden
need to widen, you need to lower your significance level from 10 to 1. Okay, he could say that. Alright, but get back to this, how's he gonna use this 3.3% number against us? Because this 3.3%, we decided it was unlikely
Very,
to happen,
right.
but it happens 3.3% of the time. That's what the realtor could say. Say, well, you know, that happens 3.3% of the time.
And he'll find me the house next
Is, so when you take a sample, 3.3% of the time, it will be that extreme. Question?
No, I think that he'll say that the majority is on the other side. So if it's only 3.3% higher, then everybody else is lower? No?
No, I think you're maybe mixing apples and oranges with like
Okay.
costs of the apartments. But our sort of mind space here is on the sampling distribution of the sample mean. All right, we're assuming what the realtor said is true, and whatever it comes out to, we're gonna evaluate the likelihood of that happening, given the true null hypothesis. So the answer I was looking for is the realtor could say this happens 3.3% of the time. And it does, right? We can't argue with that. But we decided that 3.3% of the time was not something we were willing to believe. Rather than saying, okay, this happens 3.3% of the time, you could be right, we were more comfortable saying, I think you're lying. Because our threshold for what we're willing to believe, 10%. Anything below 10%, my mama didn't raise no fool. I'm not gonna believe you. But the point I want to make here is that we could be wrong. And if our significance level is 10%, like every time we reject a null hypothesis and throw the brick through the window, and I love that analogy. So, how likely is it that we could be wrong? Yeah, I guess you could say in this case 3.3%. That's how likely it is we could be wrong. But if we set our significance level at 10%
Yeah.
before we start this test, we have a 10% chance of making that type of error. If we set our significance level at 5%, we have a 5% chance of making that type of error. And that we'll call a type 1 error, which is rejecting a true null hypothesis. So what the realtor said was true, but we rejected his hypothesis anyway. And the chances of making a type 1 error is the significance level. Okay. Any questions on that at all? All right, just one last little piece of this, and that is, suppose, as probably would be in the case in the real world, we do not know the population standard deviation. So we did our research, we talked to 50 people, we got a sample mean of this, but we did not know the population standard deviation. You remember we went through this same thing when we did confidence intervals the first time? We said, well, what if we don't know the population standard deviation? There were 2 adjustments we needed to make. Do you remember what those were? I'll give you a hint. One of them started with T, the other started with S.
T-table.
We used the T distribution, which was wider. We needed a little bit extra cushion. And what was the other thing we did?
I'll replace the data with S. S
Yeah.
data.
Yeah, we used, instead of using the population standard deviation, we calculated a sample standard deviation. And if you remember from class 1, the sample standard deviation is just a little bit bigger because we divide by n minus 1 rather than dividing by n. Okay, so if we don't know the population standard deviation, we're going to make those 2 adjustments. So let's do the example this way. Suppose we talk to actually 20 people, and we calculate a sample standard deviation of 110, and this time we calculate a sample mean of 1598. 1598. All right. So let's do critical values first. All right, so this is a T distribution. It's still our sampling distribution of the sample mean, but it's just T, so it's a little bit shorter and a little bit fatter. And degrees of freedom is what? 20, someone said 20, that's close.
It's the 68, but it's right there.
19 is the correct answer. Degrees of freedom is the sample size minus 1. Okay, so this is a one-tailed test. All right, one-tailed test, how many ways could we disprove a one-tailed test? One way. All right, and it would be with a really high sample mean. So we are interested in this upper tail. All right, that is going to be our rejection region. Reject. Okay, and our significance level is, say our significance level is 10%. So we want the T value that separates the upper 10% from the bottom 90%. 90 degrees of freedom. Could someone find that for me? Alright, so you're gonna turn to the T table in the back of your textbook. And you're gonna look in the row for 19 degrees of freedom. And then area in the right tail is gonna be 10%. And what do you come up with, Nadine?
1.32.
1.32?
8.
8? Okay, does everyone agree with that?
Yeah.
Alright, so this is our critical value. Critical value, CV. So anything to the right of this is going to fall in our rejection region. Anything to the left of this is going to fall into our fail to reject region. So now we need a test statistic for this sample mean. And just like we gave Michael Jordan a z-score, we're going to give this a z-score. Although in this case, we're going to call it a t score, because we're using the t distribution. So our t stat equals 1598 minus 1560 divided by our standard deviation of our sampling distribution and sample mean, which is sample standard deviation, 110, divided by the square root of 20. What do we get? 24?
24.5.
No, 24, that's a pretty crazy t-stat. You remember Michael Jordan was 2.3 and that was in the 99th percent? 24 is pretty far out there.
Excuse me?
Yes.
Just 1 second to solve this.
Go for it. Go for it. All right, I've got a 1.54. I'm not saying that's right.
Oh, the
It is Susie though, I mean, so I'm confident.
The bottom denominator. 24 was the bottom part of it.
Okay.
110.
Like 4.47. I just did that, yes. 4.47. 20 square root. Right? And then you.
You got it? Yes? All right, confirmed, 1.54. Our t-stat is 1.54. Let's take a look at our critical value setup. Let's make a reject, fail to reject decision. Reject, it falls into our rejection region, more extreme than the 1.328. Our conclusion is we reject the null hypothesis. All right, any questions?
Yeah.
You don't want
Yes,
the
so-
critical.
I was gonna, before we were saying that if it's less than,
The p-value?
yeah,
Okay, we could still do it the same way. But we don't do p-values as much with the t-distribution.
okay.
Simply, logistically, you don't have as much information in the back of your textbook. You can find a range with what you have in your textbook, and you can find the exact number with Excel. But for the t-distribution, in this class, we won't really bother with p-values. But, do you want to guess what the p-value might be?
Yeah.
Yeah, it would be, You got 6.18? How'd you get that?
Because
One point
1.54 on here, which gives you.
But that's the Z table you're looking at. This is Z.
Yeah.
But
Yeah, so you could estimate, with the T table, cause it gives you range.
Wait, but see, we're looking for the number 1.328.
We're not gonna do that, we're not gonna do that. I was just explaining to Dan that we don't do it as much because we don't have as much information on our T table. We could do it, we could get a range with what we have, and we could get the exact number with Excel, but we just, what we will do though is problem number 46. Let's try that. Problem number 46. I don't know what page it's on. What page it's on. My computer died. Chapter 9.
um,
46, yes.
Like being right.
Are we rejecting this because it's less than 10% significance, or because it's more than the 1.32?
We just did with the critical value. We said our test statistic was 1.54, and our critical value, our cutoff point for what we're willing to believe, which was a 10% significance level, is 1.328.
Can you,
Oh, we can keep it down, 1 second for, yeah. Alright, so 1.328 was the cutoff point. 10% of the data would be more extreme than that, so there would be a less than 10% likelihood if we had anything more than that. And we did, we had something more than that, which means it's less than 10% likelihood. So maybe it's, I don't know, 8% likely, maybe the p-value might have been 8%, or something like that. Alright, so we're doing number 46 on, which page, Lisa?
It is on page 339.
339.
It says, suppose the testing, it's testing the following hypothesis, H0 to U greater or less than 4,000, and then less than 4,000.
Okay.
Sample size is 16. The sample mean is 3920. The standard deviation is 200. And so, what is that? 0.10.
Significance level?
I'm sorry, what number is that? It's 46 and it's on page 339.
Is this all right, Lisa?
Yep. No, the first part is greater than and less than, or greater or equal to.
Greater.
The mu is greater or equal to, yep,
Okay.
that's right, and then the other one is less than.
Okay,
Got it.
got it, perfect.
And then it says compute the sample test for the T-stat.
Significance 0.01.
10%. Point, 0.01, this wrong? Is 1%?
Yeah.
Right.
It-
0.01,
Sorry,
is that 1%?
yeah, 1%, significance level 1%.
Copy your T-stat. Somewhere in here.
2.602.
Oh,
Oh, I didn't, no, I didn't
Yeah.
get it there yet.
Negative 1.6.
I didn't get where it is on the value.
Alright, we ready to do it?
Just the,
Alright, so this, we have a null hypothesis that the mean is greater than 4,000. Alternative is the opposite, mean is less than 4,000. How many ways can we disprove this null hypothesis? One, with a really low sample mean. So this is a one-tailed test. Our significance level is 1%. Let's do our critical value first. Let's set up a sampling distribution of the sample mean, but use t, degrees of freedom equals 15. All right, and we want the t value that separates the bottom 1% from the upper 99%. And what is that?
2.60.
2.60?
Yeah.
2 points, negative.
Two?
Negative 2.67.
Negative 2.60.
602.
Wait, I'm sorry. 2 point what?
602, yeah.
2.602.
Right.
Okay. So if we get anything less than negative 2.602, then we are going to reject. Anything greater than that, we're all good. So let's collect some sample data, talk to 16 people.
Wait,
Okay.
I'm sorry, it's negative because it's,
Below zero, yeah, it's
why is
it's
it negative?
below zero because yeah. So this sample, what is the assumed mean of the sampling distribution of the sample mean?
What they gave us.
4,000, right?
Yeah.
All right, and the only way we could disprove the null hypothesis is with a sample mean less than 4,000.
Okay,
So anything less than 4,000 is going to have a negative t value or z value.
so you say the median is zero.
Yep, the median would be 0, exactly. All right, so we've got a rejection region. This is our critical value. Let's calculate our t-stat. We want the difference between our sample mean and the assumed population mean divided by the standard error, which in this case is the sample standard deviation divided by the square root of sample size. What do we get for our t-stat?
Negative 1.6.
All right, that looks fine to me. Everyone like that?
Yeah.
What is our reject, fail to reject decision?
So it's greater than, so it's we fail to reject.
Fail to reject.
Yeah.
Exactly, good job.
But I rejected it because I didn't know that was a negative. Okay, anyway.
Because just the negative 1.6 is less than the negative 2.602?
Greater than.
Greater.
Because it's going closer to 0.
Yeah, I'll,
Closer to the.
yeah. This is negative 1.6 is right here, and the negative 2.4 is further out. This is out like here. This is out here. That
The
makes sense.
negative
Fine.
1.6 is
This is a bad drawing, I'm sorry.
it's in between those.
It's closer to 0.
Right, okay.
Call it 0.
But why is it closer to the middle?
So like negative 50
It's-
is all the
Because
way on
negative
this side.
2.6
Yeah.
is more negative than 1.
Right, it's closer to the middle.
Yeah.
1.6, negative 1.6 is closer to the middle.
Yeah,
Right, closer to the positive.
Right.
yeah, 0, negative 1.6 is here, here, and negative 2.6 is here.
Oh, okay. So that we're rejecting closer to.
You fail to reject it.
It is not in our rejection region, which is more extreme, meaning less likely.
Okay, but if it was further to the left,
You would reject it.
then we would reject it. We want it always closer to the 0.
If it's, yeah, if it's
If it's in.
Negative 3.4.
on this side, fail to reject, on this side, reject.
Okay.
So we're accepting it, how do you say that again?
Fail to reject.
Fail to reject, okay.
Because we're statisticians and we don't like accept.
Fail to reject.
Fail to reject.
Got
We're
it.
very skeptical of everything.
Okay, good, let's,
Anytime it's more extreme, it's failed to reject.
what's that?
Anytime you have a more extreme case, then fail to reject.
Well, I would say me say this, our Z stat was less extreme than our critical value, so we failed to reach it.
Math is not based on the t-stack, no.
Alright, let's take a quick 10, because we do not have a whole lot. I'm just gonna go through the slides, which are all review at this point. We've already gone through the fundamentals. So, take a quick 10 or no break at all?
Equation.
No, just,
No,
No break at all?
Let's keep going, we can do this.
No, that's not the T.
I mean, if you need a break,
We're
then.
solving for the equation.
Let's take a quick 10, like a real quick
T-stat is
10.
stating the significance level.
Let's come back at
Like
8:09.
that.
That's 7
Reject
minutes.
after.
7 minutes.
We failed to read.
You negotiate.
I reject that.
Jack that, okay. Yes.
But it's two, because I was looking at my blackboard, so it's 256, and the extra, can I redo that? Because I got it.
Wait, quiz or
No,
Excel?
it's-
Great. Think you wanna redo the Excel?
When you look this up,
Yeah,
you get bothered.
because I was, I'm
it's
A,
negative,
and
the
then
system that,
before
the
I got
left
like,
side of.
almost had a heart attack.
But why is it on the left side?
Just remember, I told you when you go.
So I can redo the whole
Yeah.
and then the, wait, show it.
You can redo any Excel
Because
exercise.
if it was the other way
Right,
around,
right, this one is telling you
that is true.
that
what it
is,
is.
this is great.
You have the answers now for one reason.
Oh, do you really?
Yeah.
I was gonna ask you, how do you check what you
You
did
click
wrong?
on my grades,
For
you
the
Uh-huh.
click on the quiz,
It's
Okay.
not
and
less
you click
than.
on the score that you got.
Yeah.
And if you haven't even had as many
Because if I
grades,
do
you
it,
click on the
you
yellow
do it the
bubble
other
that
way,
says name grade.
and you get 2.6, right, and then you reject everything I say.
Can I
You wind
show
up
after,
rejecting.
let's do this after
Right.
test?
Yeah.
You gotta watch out for this.
Does that make sense?
Kind of.
Hey, I should have printed out my, are you going to the festival? You are, I should have printed out my super thing. I know, but I'm hooked up with my resume computer, my resume.
And that's only because.
It's fine, I'm gonna email one of my teammates.
Oh, okay. And if it was more towards the left, then obviously. Rejection.
Okay.
Because it's true to the right and closer to the middle,
Right.
then obviously it's less likely farther than the critical value. I don't know,
Okay.
that helps.
Yeah, just, I mean, if it was on the positive side, and it was 2.6 in the critical value and T value is 1.6, that's less than, because it was less than, I was confused with the full value. When, Professor, when this, the negative 2.6 was our critical value, and the T value, the T stat was negative 1.6.
Yes.
I'm blanking out here, the negative 1.6 is greater than or less than negative 2.6?
It is greater than.
It is greater than, okay. Okay. The negative
Thanks for
one.
coming, do you like my story?
Okay,
And the reason why I chose to go with the negative
is because we had the 3920 as our
Well-
sample mean, minus the,
Yeah, well, you can often figure it out that way, because, well, you'll never get a trick question in this class, but the real way you'll figure it out is looking at the alternative hypothesis. Under what grounds would you reject a null hypothesis? That would be something lower than 4,000. And
oh, okay.
anything lower than 4,000 is gonna have a negative T value.
So this, really, this right here is the indicator of
Yeah.
positive and negative.
Yeah, exactly. And actually, I think when I learned stats the first time, I memorized that the greater than or less than points to the rejection region. If that helps you, that's great, but I think it's better just to think it through,
Okay.
just to say, where would it be?
And let me ask you, I had made a note for myself. One of the first two tail tests that we did before, where we had
I don't know
the
if that's the goal. Oh, Marie.
significance level is 0.5%. We had the critical value of 1.96. Is that because, just like with the Z table, we have the 95% confidence that equals the Z
Exactly.
of 1.96?
Exactly.
Okay, so it's not so much that both sides are actually equal 10, which would be at 90%, or we're just looking, we're considering the 5% only and using the 95% C.
Yeah, so it's 5% and 9%, so our significance level is 5%,
I
so
mean, I
we
think
have
like,
5%
you
chance
have
of
like
making a mistake.
percentages,
Okay.
you have
And so
people
2.5% on
right
either
now,
side.
it's like, I
Oh,
can run
okay.
with it.
And maybe what you're thinking of is the exact same logic of the confidence interval. We could make a 5% chance of
Right.
making a mistake. 2.5% on the up tail, 2.5% on the lower tail.
Okay.
And I have actually taught it that way sometimes. I start with confidence intervals. In fact, last night, because somebody said, well, couldn't we do a confidence interval?
Right.
So I said, sure, let's do a confidence interval.
Okay.
And we did it that way. And then I taught them this stuff. It's the exact, just mirror image.
National region that
Okay.
they're working on.
Great.
So
Great,
before I can even
Yeah.
answer the question, which is interesting in knowing, I needed to know the region that I'm working with, because if you tell me Texas, then I can go into the legislative piece in Texas. But if you tell me New York metropolitan, then I go into my legislative folks at the state level. But there's no state.
Like, what I got was that he was looking to see legislation in general, like the US legislation towards, or like HIPAA rules, or like federal laws that are going to either hinder the growth of the company, or.
Well, that we can determine, because Trump is about to revamp the whole ACA piece.
So,
So that we can't give him an answer. If I can give you that about
oh,
this.
I think we can, it takes a
We can tell
while
them
to
what we
get
have
laws,
now.
yeah. It
Yeah,
takes
but
a while for laws to get regulations to get passed, so we're gonna keep looking for like what's right now.
we're trying now, we can just, you can search it out.
Yeah,
That's not
exactly.
an issue. What he wants to know is where we're going, and that's the question he asks, where we're going with the legislation. Which at that point, we would have to put some feelers out there in terms of what the relationship is.
Well, I think we can look at Trump's, viewpoints on
Right now,
healthcare.
Right now, to be quite frank with you, even if we were to change up the ACA, this is my opinion.
Yeah, but the ACA doesn't have to do with,
If it was,
he's worried about HIPAA laws and it's gonna hinder his.
I don't think it's really touch with the laws that much. I think they're looking more in terms of the reimbursement based on,
But there is no reimbursement for his telemedicine.
you can still do it.
No, but what he's doing, and this is what I don't understand, this is the question I have, he charges a client $15 a month, whether you use it 20 times,
Which I think is ridiculous.
no time, $15 a month.
Which I
Every
think is-
time you call in, you're not getting charged, you're not
Which is-
getting billed.
I think that's insane, because anytime anybody does call with the current system, it's $50, and then the rest is
Well,
covered.
the current system is the current system that we use, there's over 50
Yeah, but I'm
telemedicine
saying-
things.
I understand, but it would make no sense to charge.
That's what I don't get what he's doing.
Okay, so then we're basically agreeing.
Yeah, but what
We're
he's,
basically agreeing.
yeah, but when you're talking about legislation, that has nothing to do with reimbursement. He's not getting reimbursed for anything.
No, he gets to bill it, he wants to be able to bill it.
No, he bills clients. He doesn't bill their insurance company or
So
anything
he's
like
not
that.
looking to bill Medicaid or Medicare?
No.
Okay.
No. So don't worry about like ACA and the legislation in that way, because that's not how they gather their money. That he's looking at is there's regulations gonna pop up about, electronic transfer of patient information or, I don't know, whatever, any kind of legislation that.
Then that's not so much federal, it's state. You
Then we can
understand
ask him, I don't know if it is, I don't know legislation. Maybe then that's a question that you can ask him. What states in the next 12 months are you looking
what-
to implement?
Texas.
Yeah, I mean, but in the next 12 months, have a timeline, like ask that exact question. So then that will be part of our proposal, we'll look for state legislation in New York and Texas. And he probably wants to do Connecticut and, just tri-state.
To be honest, I don't want anyone
doing it, or.
I don't want to,
But-
so I'm not gonna create more work for myself, I'm gonna use one example, which is the metropolitan.
Checking that out next time.
Find out.
All right, let's go ahead and get started.
I have a question.
Okay, start with the question.
Do you ever do this, like when in life, when you're like buying an apartment or something? Like, I'm curious, because you're, like, have you ever, honestly?
Overwhelming evidence to the contrary.
And anything, like buying a car, buying anything, anything.
That's a good
That's a big no,
question.
it took you too long to answer it.
Yeah.
Yeah.
I know, like, because if you think of this hypothesis testing, the standard of proof is very high. Like, it has to be less than 1% likely or less than 5% likely before you would make a rejection decision. I mean, I feel like we all have a higher significance level than that. You just get a feel, you're like, ew, that guy kind of creeps me out.
Because when you, like,
Reject.
even with like the rent, for instance, like the 1560 and the 1586, it's like what, $16 difference?
Mhm.
You're gonna just, alright, not a big deal.
Well, I think the valuable thing from a practical standpoint is, so it's $26 difference,
Oh,
is that a huge difference, or is that a small difference?
Small difference.
And
It matters to who
you,
we're
okay, so
talking
you
to.
said it's a small difference, $26, but what was the p-value?
Yeah, that's just the mean of the, like,
What did our p-value come out to?
3.3,
6.6.
or 6.6.
Right.
Our p-value came out to 6.6. So when you heard $26, did you think there was more than a 6% likelihood of that happening, or less than a 6% likelihood?
I think it's less than 60, I'm 6%,
Really?
I think
So,
so. 6 doing that.
I feel like you said only 26 like was a small amount. And then once we found out that there's less than a 6% chance of that happening, I might say, wow, that's really unlikely.
Right.
So just being off by $26, as statisticians we now know is really unlikely.
So you're saying, you're bullshitting me, I got your bluff, so.
Yeah.
Pretty much, and who do you really wanna do business with if they're bluffing you?
Yeah, and you thought you could get away with an extra $26,
Yeah.
but
And that's where you see mom and everything.
I'm in Rachel. All right. So, what did we do the last 2 hours? We looked at hypothesis testing. We looked at one-tailed tests. We looked at two-tailed tests. We looked at the possibility of error. Remember I said type 1 error. We'll just revisit that. And we learned how to use the t-distribution in the real-world scenario where we don't know a population standard deviation. Right. In hypothesis testing, we make a statement. We call it a hypothesis about some characteristic. Then we take a sample in an effort to establish whether or not that statement is true. If the sample produces results that would be highly unlikely under the assumption that the statement is true, then we conclude that the statement is false. We have our null hypothesis, we have alternative hypothesis notated this way, null hypothesis this way, alternative hypothesis notated that way. Statisticians will often call the null hypothesis the status quo, the no change, and we will look for overwhelming evidence before we make a change. So if a machine is malfunctioning and we see it malfunctioning a little bit, right, maybe that's not good enough to justify the expense of a whole new machine. Or maybe that's not good enough to justify getting a whole new supplier if we see just a little bit of things that are out of the ordinary. We may want overwhelming evidence to the contrary before we change what statisticians will often call the status quo, null hypothesis. All right, we looked at ways we could set up hypothesis testing. One-tailed test, a mean is less than or equal to a certain amount. Alternative is the opposite of that. We could have the other tail, a mean is less than or equal to a certain amount, and the alternative is the opposite of that. We also looked at a two-tailed test. Remember, there are two ways to disprove a two-tailed test, and we had that little nuance where we had to double the probability because there were two different ways that could be disproved. All right, so this is a one-tailed test. We talked about the sampling distribution, the sample mean. That tells us everything. Remember I started class with this. I said, well, how could we possibly know how likely it is to have a sample mean that extreme? The answer is because of what we know about the sampling distribution of the sample mean. We chose significance levels, we established this decision rule, we talked about accepting versus failing to reject the null hypothesis, we talked about p-values, and then your slides will just have a generalized step-by-step procedure. Alright, sampling distribution, the sample mean is what gives us everything we need to know. everything we need to make this decision. And I was just having a discussion with Charlene where she said, well, if the realtor was off by $26, that doesn't seem like a huge amount, right? Am I
Yeah.
accurately reflecting what you said? And then I said, well, $26 doesn't seem like a huge amount, but then we calculated the p-value at 6.6%, and we found that that $26 was in this crazy extreme edge. So now we're, as statisticians, have a basis to saying that's really unlikely, even though it seemed like a small amount. You thought you could smoke that $26 by me, but you actually can't. All right, so, significance level. Significance level, denoted by this little squiggly sign, is the probability that defines just what we mean by unlikely sample results under the assumption that the null hypothesis is true. So if our significance level is 5%, we're going to believe anything that is more likely than 5%. But if it's less likely than 5%, that's our cutoff for what we're willing to believe, the unlikely stuff we're willing to believe. Significance level. All right, so our decision rule. Now, we've got some information here about whether we reject or fail to reject. Let me see if I can go through it without sounding confusing. If we have a lower tail, one-tailed test, if we have a z-stat that is less than the critical value, then we reject. If we have an upper tail test, if we have a z-stat that is really, really high, like Michael Jordan's z-stat, and is higher than our critical value, or our cutoff point, then we reject. How do we calculate those z-stats? Or wait a minute, where's my z-stats? I'm skipping ahead a couple slides. So remember we calculate our z-stat, our sample mean that we calculate based on our research. The difference between that and the assumed population mean divided by our standard error, which is also known as the standard deviation of the sampling distribution of the sample mean.
No, I don't.
What's that?
We use the bottom one.
Yep, this is the same. This symbol here, standard deviation of the sampling distribution.
That's gonna confuse me.
Yeah,
It is, yeah,
Just don't
like,
show me that one, show me just the bottom
please,
one.
yeah.
it comes out to the same answer, doing it the same way, right?
It is, you have to know this though. You have to look at this, you know that this means standard deviation,
Okay.
and you know this little X bar,
The one, the bottom is the one.
sampling distribution of the sample mean. So this is the standard deviation of the sampling distribution of the sample mean. And we know what the formula for it. Population standard deviation divided by the square root of the sample size. Alright, so once we've calculated our test statistic,
And
And
these
once-
numbers are, it corresponds to what's in the textbook, right? The 9.1A and the 9.3?
yes.
Okay, just making sure.
Yes. And we calculated our critical values, then we can set everything up. Alright, suppose we have a significance level of 5%. This is a one-tailed test in the lower tail. Our critical value is 1.65. We know 1.65 is the z-value that separates the bottom 5% from the upper 95%. And anything less than negative 1.65 would be our rejection region. Alternatively, if this is an upper tail test, anything greater than 1.65 would be in our rejection region. Question?
So if anytime the question says the hypothesis is greater than or equal to, you're always gonna have a negative z-score because you're gonna look at the bottom 5% of our, if it's less than or equal to, you're gonna look at a positive, like 1.65.
I think that was right. I'll just need to, you said the null hypothesis
Is greater than or equal to, so you're looking at this side, so it's negative.
so greater than, or the null hypothesis is greater than or equal to, you could disprove that with an extremely small.
Small, yeah, so you're gonna have a negative z-score. Yeah, okay.
Is it two tails when it's equal?
It is two-tailed. The only time you'll have a two-tailed test is when you see the null hypothesis say equals.
Yeah.
Because the opposite of that is does not equal, and there are two ways to disprove, or two ways to prove that it's not equal.
Yeah.
Really high or really, really low. Right. All right. Okay, so we talked about this idea of failing to reject versus accepting. So statisticians like to say they fail to reject. They don't like to accept. The bottom line on the reason why they do that is because it makes them less likely to be wrong. So they can always say, I never accepted the null hypothesis. All I did was fail to reject the null hypothesis. Does that make sense? All right. P-value. What is our p-value? That is the probability that if the null hypothesis is true, we would randomly produce a sample result at least as unlikely as the sample result that we actually produce. So we assumed what the realtor said was true, and then we looked at our sample mean, and we said, hey, if what the realtor said is true, what is the likelihood that we would get that sample mean? Well, only 6.6%. That was our p-value. And we compare our p-value to the significance level, and if the p-value is less, we reject. Alright, we've got a generalized procedure on slide 15. State the null and alternative, choose a test statistic and significance level, compute the value of the test statistic from your sample, apply the appropriate decision rule, and make your decision. We have two ways we could make this decision. One is the critical value version. The other is the p-value version. We started with the p-value version. We said if the p-value is less than significance level, reject. And then we went back to the critical value version, which is similar to what we did with confidence intervals, with the 1.65 plus or minus, the 1.96 plus or minus, or maybe it's a one-tailed test, so we're going to have a slightly different number. And if the test statistic falls in that rejection region, whichever it is, upper, lower, two-tailed, then we reject. Yes?
Why, when do we, I don't understand when the t-distribution, why don't we use p-values for that? I mean, what, can you just go over that again?
Yeah, we could, statisticians do. The reason why we skipped over it is because we just don't have enough information in the back of our textbook to get p-values for the t-distribution. You can see that the t-distribution in your textbook just has less information on it. So it's harder for us to zero in on the actual answer. And that's all it is. It's just logistics. And I think actually for your Excel assignment this week, you will do some p-values for t-distribution. All right, possibility of error. Type 1 error, rejecting a true null hypothesis. Remember I said we're going to get really mad at that realtor, we're going to go throw a brick through his window, but there's a possibility we could be wrong. And we can never be 100% sure when we reject a null hypothesis. We could be rejecting a true null hypothesis. What are the chances of rejecting a true null hypothesis? The significance level. Whatever we set the significance level out at, that's the possibility of making that mistake. And then a type 2 error is accepting a false null hypothesis. So instead of saying I reject, you're saying I accept. Do statisticians ever make this mistake?
Yes.
Do they? Statisticians never make this mistake.
Because they always say.
Because they always say, fail to reject. You all are statisticians now, and you will never make this mistake. Welcome to being a statistician and never making this mistake.
I'm sorry, when you said the significance level, you meant it by maximum probability and you would use a 10%.
You could use 10%, you could use 5%, you could use 1%, whatever your... Basically, whatever is the cost of a type 1 error high?
Yeah.
Like maybe making a type 1 error would mean you have to build a whole new factory. Alright, because you say, alright, this old factory, it's causing too many problems. So if I'm going to find what I call overwhelming evidence to refute that the factory is operating smoothly, then I have to spend millions of dollars. If I want to guard against a type 1 error, that mistake, then I would set a really, really low significance level. Say, I only want to do that if I'm damn sure. Like there's, 1% possibility of me being wrong. That make sense?
Yeah, I'm just looking in terms of, making the connection to a life situation like you just did right now. Like some people say, well, should we move the factory overseas and what are the chances that we're gonna make more money that way?
Okay, I guess there's lots of complicated steps in that.
Yeah,
And lots more than just one hypothesis test, but yes. All right, does that answer your question?
it does, very much
Excellent.
so, thanks.
All right, so type 1 error, we know what that is, we reject a true null. Type 2 error is statisticians, such as yourselves, never make type 2 errors, because you always say fail to reject. Okay, so this is just a process for the two-tailed test. If the statement that, say, a realtor made is an equality, that the mean is equal to this, we have two ways to disprove that. Two ways to prove that the mean is not equal. So for the significance level, we'll split that in two tails. Critical value, we'll have an upper and lower critical value. Calculate the test statistic the exact same way, one-tailed or two-tailed. The p-value, remember we have to double it. And if this helps you, we reject a null if the absolute value of the t-stat is greater than half the significance level. So the absolute value meaning if the critical values are negative 1.65 and positive 1.65, if the t-stat falls outside of that, then it has an absolute value greater than 1.65. Or the p-value version, of course, if the p-value is less than the significance level, reject. Alright, visual aid for our two-tailed test, half the significance level here, half the significance level here, critical values on both sides, and our rejection region over here, rejection region over here. Okay, we form our hypothesis test this way. Alright, now what if, as is so often the case in the real world, we do not know the population standard deviation? And why would we? Right? We're new to town, new to St. Louis, we're just talking to this realtor, but we want to gather some information to confirm or deny what he says. We will have to make two adjustments. One, we will use the t-distribution, which is a little shorter, a little fatter, which gives us a wider confidence interval.